You know, it's funny. We just go about our day seeing the world in all its color, and we just assume everyone else is too.
Right.
But today's deep dive is all about kind of challenging that assumption
Okay.
because we're diving into color blindness,
All right.
and we got some really fascinating information from you to get us started.
Yeah, it's a surprisingly common condition.
Yeah, I was really surprised actually to learn that it's estimated that like 300 million people worldwide experience some form of color blindness.
Yeah,
That's a lot of
it's
people.
a huge number.
Yeah. I mean, that's like I don't know, the entire population of Brazil.
Exactly. It's
Wow.
not a small segment of the population by any means.
And I'll admit, I before we got started with this deep dive, I kind of had this picture in my mind of color blindness as like you only see black and white, like an old movie or something.
Yeah, that's a really common misconception.
Is it real?
Oh yeah. While complete colorblindness does exist, it's incredibly rare.
Okay.
For most people with color vision deficiency, it's more about difficulty distinguishing between specific colors or shades.
So it's not really like seeing in grayscale. It's more like nuanced than that.
Exactly.
Okay. So instead of grayscale, is it more like seeing a limited palette of colors or maybe colors appearing less vibrant or something like that?
You're on the right track.
Uh-huh.
To really understand how it works, we need to take a quick peek at how we even see color in the first place.
Ah.
It all starts with these specialized cells in our eyes called cones.
Cones, like pine cones.
Ah, not quite.
Okay, sorry. Sometimes my brain just like makes these weird
I know,
connections.
forget it. These cones are microscopic,
Mm.
and they live in the retina of your eye. And we have three types of cones.
Cree.
Yeah, each sensitive to a different range of light wavelengths: red, green, and blue.
Ah, so it's like our eyes have their own internal RGB system, just like our TVs and computer screens.
Exactly.
That's so cool.
Yeah, and when all three cone types are functioning typically, we call this trichromacy. You
Trichromacy.
can perceive that full spectrum of colors, but even the slightest variation in these cones can lead to color blindness.
So you're saying like if one of those color channels in our eyes is a bit off, that's when we get color blindness.
Exactly.
And if it's like really off, maybe that's where that grayscale misconception comes from.
That's precisely. And it's often genetic, especially the most common type,
Uh,
red-green color blindness. And this is where it gets really interesting. This type of color blindness is passed down through families, and it's way more prevalent in men.
Wait, really? I'd always pictured color blindness as one of those things that could happen to like anyone.
It's a common thought.
Why would it be more common in men?
It all boils down to our chromosomes,
Uh-huh.
specifically the X chromosome.
Okay.
Men have one X and one Y chromosome,
All right.
while women have two X's. The genes for red-green color vision are located on the X chromosome.
Okay.
So if a man inherits an X chromosome with that gene for color blindness, he'll have the condition. Women, on the other hand, have that backup X chromosome.
So it's like having a spare tire, just in case one gets a flat.
Exactly. That's a great way to put it.
That makes a lot more sense now. But I'm guessing not all color blindness is about red and green, right?
You're right. It's the most common.
Yeah.
But color blindness actually exists on a spectrum with a whole range of variations.
Okay.
Besides red-green, there's blue-yellow color blindness, which impacts the ability to differentiate between those colors.
Uh-huh.
And then there's monochromacy, which is closer to that black and white vision we talked about, but again, it's extremely rare.
Wow, this is way more complex than I realize. So within those types, are there different levels of severity? Like for red-green color blindness, are there varying degrees of how someone might perceive those colors?
Yeah, you're exactly right. There are varying degrees of severity. Let's take red-green color blindness as an example.
Right.
Within that category, there are variations like deuteranomaly, protanomaly, and then protanopia and deuteranopia.
Okay, I'm not even going to try to pronounce those.
Right.
Yeah, they're quite a mouthful.
They are they are. But
But let's stick with red-green color blindness for a minute. You mentioned like those different variations, but it seems like at the end of the day, it all kind of boils down to trouble seeing reds and greens, right?
well, it's a bit more nuanced than that. It's not just about seeing red and green. It's about how those colors are perceived because of those, subtle differences in the cone pigments we were talking about.
Right, right. So it's the cone pigments that are making those variations distinct. Okay, can you give me an example?
Absolutely. Let's take deuteranomaly.
Mm,
It's the most common form of red-green color blindness.
okay.
With deuteranomaly, it's the green cone pigment that's atypical.
Okay.
And this can make greens and yellows appear reddish, making it difficult to tell those colors apart.
So instead of seeing a vibrant green, someone with deuteranomaly might see it as more of a like a muddy brown or reddish hue.
Exactly.
I can see how that would make things like picking out ripe fruit a bit tricky.
Exactly.
Imagine trying to find a ripe avocado. Like, forget about it.
Exactly. And what's fascinating is that our sources say many people with mild color vision deficiency don't even realize they have it until someone else points it out. It might not be as obvious as mixing up bright red and green.
Wow, that's wild. I never considered that someone could like go their whole life without realizing that they see colors differently. Like
Yeah.
that's that's mind-blowing to me. It makes you wonder how many people are out there that have some degree of color blindness and they don't know it.
It is. It's definitely something to think about it, and it highlights the fact that color blindness exists on a spectrum,
Right.
from mild difficulties distinguishing certain shades to more significant challenges.
Okay. So we've talked about, the science behind it, but I'm really curious about the practical side of things. Like what are some everyday situations where color blindness could make life, I don't know, tricky?
Sure. Our sources point out several areas. Some professions immediately come to mind, like pilots, electricians, or designers, where color differentiation is absolutely essential.
Right, right. And those fields, like mistaking one color for another could be like actually dangerous.
Exactly, yeah.
Yeah.
But it goes beyond specific careers. Imagine trying to follow a colored ball against a similar colored background in sports, or navigating a city using color-coded maps. Even something as simple as cooking, where you're judging doneness by color, can be impacted.
You're right. I never even thought about those everyday situations.
Yeah.
It really highlights how much we rely on like accurate color perception without even realizing it. And it makes you realize how important accessible design is.
Yes,
And not just for things like, websites, but for the real world too.
absolutely. And speaking of accessible design, there have been some incredible technological advancements in recent years to help people with color blindness, specifically glasses and contact lenses, like EnChroma and Colormax.
Oh yeah, I've heard of those. How do those even work? Do they magically give someone the ability to like see the missing color? It almost sounds too good to be true. Like those glasses are some kind of high-tech superpower or something. Are they really that life-changing?
They can be pretty close for some people. They work by filtering specific wavelengths of light. And it's not about, adding back missing colors,
Right.
but more about enhancing the contrast between colors that might, look similar to someone with color blindness.
So it's like they're fine-tuning the color signals that are being sent to the brain.
Exactly. And for some people, it can be pretty remarkable. They might see a wider range of colors or experience certain colors more vibrantly for the first time. It can be an emotional experience.
Wow, I bet. It really shows how technology can have a real impact on improving people's lives. And speaking of impact, I was reading that in the US, color blindness is actually recognized as a disability under the Americans with Disabilities Act,
It's great.
which makes sense, given all the potential challenges we've been discussing.
Absolutely. This recognition is huge, especially in areas like employment and accessibility.
Mhm.
Employers need to provide reasonable accommodations for employees with color blindness.
Right.
And it emphasizes the importance of designing things like websites, public spaces, visual information
Yeah.
with color blindness in mind.
It's a good reminder that designing for accessibility benefits everyone.
Exactly.
Not just those with specific needs.
Yeah.
It makes the world a more inclusive place. So we've covered so much ground here today, from the science behind color vision to the real world challenges and the incredible technological advancements related to color blindness. As we wrap up this deep dive, what are some key takeaways you hope our listener will walk away with?
First and foremost, I hope it's clear that color blindness is much more common and nuanced than many people realize. It's not just a matter of seeing in black and white. It's about how our eyes and brains process color information and the varying degrees to which that can be affected.
Absolutely. It exists on a spectrum, and it can impact people in different ways. And as we've learned, while there are ways to mitigate some of the challenges, like with those incredible glasses, it's just as important to raise awareness and foster empathy.
I couldn't agree more. There's a fantastic online tool called Cobbless, It's a color blindness simulator. You can upload images or browse the web as someone with different types of color blindness.
Oh, that's a great suggestion for our listener to really understand what it's like stepping into someone else's shoes, even virtually, can be incredibly eye-opening. So we encourage you to check out that simulator, experience the world from a new perspective, and who knows, maybe you'll be inspired to approach design and information in a more inclusive way. This has been a fascinating deep dive. Thanks for joining us.